Manson Construction Company presents Ergonomic Principles, fitting the job to the worker. You may have heard of the term ergonomics from time to time and wondered what it has to do with you. Put simply, ergonomics is the study of how human beings interface with their workplace. Specifically, it involves the design of equipment, devices, and methods we use at work, as well as the work environment itself. It takes into account not only how tools and machines are made, but also how we as humans are made, how we move, and how we interact with our environment. The overall goal of ergonomics is to reduce risk factors and design job tasks to minimize the stress on the human body, ultimately improving job efficiency and productivity. This can't be achieved solely through engineering, however. A tool with an ergonomic grip is not any more helpful if it is used incorrectly. This is why ergonomic intervention strategies usually involve three methods. These include engineering, to design tools or equipment to maximize the human interface. Administrative methods, to develop work processes such as job rotation and workload distribution. And behavioral-based methods such as pre-work warm-up stretching, neutral work postures, and proper material handling techniques. By identifying and reducing risk factors in your workplace, you can lower your risk of serious injury or disability. The main work-related risk factors that we address in ergonomics include excessive forces on the body, repetitive motions of the body, awkward postures, exposure to vibration, contact stress, and exposure to adverse environmental conditions. Any force you exert creates reactive forces inside your body as a result of muscles contracting. These forces, if great enough, can cause injury. Obviously, the heavier an object you handle, whether by lifting, carrying, pushing, or pulling, the greater the force your body needs to generate. However, the weight of materials you're handling is not the only factor to be concerned about when trying to prevent an injury at work. It is important to remember not to jerk on materials when lifting, pushing, or pulling, as this can cause a sudden tear of your muscle tendons, ligaments, and joints. Jerking on materials when working in an awkward posture is especially dangerous. It is important to remember that internal forces in your body follow basic lever principles, much like a seesaw. When you reach out away from the body to lift something, you increase the length of the lever arm in front of the spine. However, the muscles in your back that work on countering the increased force in front of the body are always acting at a fixed, short lever length from the spine. The further a load is positioned away from your body, the greater the force your back muscles need to counter the load. The total force you are subjected to during lifting includes the weight of the material being handled, plus the weight of your body being moved against gravity. When lifting in a bent-over posture, pressure in your lower back or lower lumbar spine will increase significantly in response to the weight of the object being lifted and the weight of the trunk as it moves forward of the body's center of gravity. The shock absorbers in your lower spine, called discs, will be compressed and subjected to large amounts of pressure as well. Increasing the pressure in your spinal disc to high levels over time can actually cause the disc to rupture or herniate, which is when the inner gel is pushed out of the disc wall, causing a lot of pain and possible disability as it pushes against nerves or the spinal cord. Since the length of a lever can affect the actual force required to move an object, it is not uncommon for a person to strain their back, even rupture a disc, when lifting something not considered heavy, but which is lifted away from the body. Spinal injuries are most common in the lower back because that is where most of the force is generated during bent-over postures and lifting. Another key risk factor to avoid, especially when you are lifting, is twisting. Twisting and bending over to lift something is a combined motion that dramatically increases your risk of a serious back injury. Good ergonomic solutions include using assistive devices like dollies and forklifts to eliminate reaching when lifting, reducing the weight of materials, and designing your work area in a way that will reduce your need to twist, bend over, or reach above your head. The main risk associated with highly repetitive movements of your body is muscle fatigue. As long as your muscle is undergoing contractions, it must receive a constant supply of oxygen and nutrients from blood flow. When the repetitive motions of your muscles become too rapid to allow enough oxygen to reach the tissues, muscle fatigue occurs. When working, you should be aware of the early signs of muscle fatigue, such as muscle tremors of the affected limb, weakness, pain and discomfort. Ignoring muscle fatigue and pushing your body to do more without allowing your muscles and other body tissues to rest significantly increases the risk of overuse injuries such as painful muscle strains. It's important to remember that conditions caused by overuse, such as joint sprains and muscle strains, are usually distinguished by the early onset of soreness or mild pain before progressing into more severe, disabling pain. This highlights the need for taking breaks every now and then, even if just for a minute or so, to allow tissues the time to relax and rejuvenate. Looking at ways to reduce repetitive movements by redesigning your work is a key ergonomic intervention. Awkward postures are postures that deviate significantly from the neutral alignment of the body. The overall ergonomic goal is to remove work tasks that force a person to work in awkward postures or to prevent work habits involving awkward postures. So what would be the ideal working position? Ideally, when you work, you should aim to work in a neutral posture. An ideal neutral posture, when standing, exists if a vertical line runs through your ear, shoulder, hip, knee, and ankle. An ideal neutral posture for your upper arm is when it is aligned vertically on the side of your trunk. An ideal neutral posture for your elbow is either fully extended down by your body or bent to 90 degrees. An ideal neutral posture for your forearm is when it is rotated so that your palms face inwards, as they would when you shake another person's hand. An ideal neutral posture for your wrist is when it is positioned straight and not extended, flexed, or angled towards either side, and an ideal neutral posture for your head, neck, and trunk are when they are not flexed, extended, bent to the side, or rotated. It is not always possible to position yourself to work in a neutral posture, but it is important to be aware of when you are working in a stressful posture. Some examples of stressful postures include working with your arms constantly held away from your body, or with your arms held overhead for a prolonged period of time. Working with your wrists bent for a prolonged period of time. Working with your back bent over or twisted for a prolonged period of time. Working in a squat position for a prolonged period of time. And sitting slumped in a chair for a prolonged period of time. In general, any awkward, non-neutral posture, if maintained for prolonged periods of time, may contribute to a soft tissue injury. By avoiding awkward postures whenever you can, and relieving them by simply moving out of the posture, or by using posture relief stretches whenever possible, you can avoid serious injuries. Arranging your work area to make it easier to work in a good neutral posture is a key ergonomic principle. Prolonged exposure of your hands and arms to certain levels of vibration can result in increased muscle tension, constriction of blood vessels, and the irritation of nerve endings. Hand and arm vibration exists, for example, when you use power tools such as sanders, grinders, and chippers. You should minimize any prolonged exposure to vibrating tools whenever possible. Taking frequent breaks from using a vibrating tool is a good idea, particularly if you are holding the tool in an awkward posture. You can also be exposed to whole body vibration when standing or sitting on a machine that vibrates. For example, you are exposed to vibration when driving your automobile or when operating a forklift. Vibration can be especially bad because prolonged exposure can harm the discs in your spine. Vibration can cause spinal discs to lose fluid faster than normal and may actually interfere with the nutrition of the disc. The combined effect of vibration and bad or awkward posture leads to increased pressure in the discs and poor disc nutrition. After prolonged exposure to seated vibration, the discs in your lower back actually become dehydrated, losing as much as 20 to 30% of their fluid. This makes your discs more vulnerable to being injured when there is a sudden twisting motion of your upper body. Due to the combined harmful effects of poor seated postures and exposure to vibration, drivers and seated operators of forklifts, cranes, and other heavy equipment should use a lumbar support cushion to help keep the back in proper alignment. Lumbar cushions, when used properly, have been shown to help reduce disc pressure and facilitate disc nutrition. Whenever you get ready to stand after being exposed to prolonged sitting and vibration, you should avoid twisting out of a vehicle by moving your legs and hips first before moving your upper body. Additionally, drivers and equipment operators should, as soon as they exit the vehicle, stand and perform a few slow back extension stretches before doing any lifting or other strenuous activities. Ergonomic interventions to reduce your exposure to whole-body seated vibration include using lumbar cushions combined with air ride cushion seats to dampen the vibration. You can also use anti-vibration pads or other absorption systems on standing platforms that vibrate from equipment. Environmental stresses such as cold, heat, air quality, and noise are also ergonomic issues that require serious attention in your workplace. Exposure to cold, which is considered to be below 20 degrees centigrade or 68 degrees Fahrenheit, adversely affects skin sensation and your ability to use your fingers with good dexterity. Sensory feedback from your muscles is altered by exposure to extreme cold and makes it difficult to judge how much force is necessary to complete a manual task. This increases the risk of overexertion. Cold temperatures also require you to wear heavy clothing that can interfere with your movement, and gloves that can interfere with your grip strength. Gloves, depending on the type, can reduce your grip strength by as much as 25% and cause you to overexert when using force with hand tools. Cold temperatures also cause your blood vessels to constrict, increasing the risk of frostbite, and magnifies the harmful effects of vibration exposure. Heat stress and accelerated fatigue caused by high temperatures are common risk factors in non-climate controlled work areas, especially if accompanied by high humidity. Muscular activity during strenuous work produces heat that is dissipated from your body by processes like perspiration. As your exposure to heat and humidity increases, your metabolism also increases, leading to quicker onset of fatigue. Noise is another environmental hazard that you should be aware of. Noise activates the nervous system in the same manner as mental stress, especially when noise levels exceed 85 decibels. In addition, noise can interfere with communication or cause a mental distraction, leads to errors in job performance or even accidents. Prolonged exposure to high noise levels can cause permanent hearing damage. This is why it is important for noise levels to also be assessed in an ergonomic program and that hearing protection be worn when required. Exposure to equipment exhaust and hazardous fumes is a very real hazard that must be addressed. Make sure that all workplace environments are tested for atmospheric conditions and that a proper respiratory program is in place when necessary. As you can see, ergonomic intervention is a proactive way to prevent injuries as it addresses the causes, not just the symptoms. Ergonomic interventions aim to minimize your exposure to workplace stress by utilizing control methods such as heaters, fans, shading, work timing, job modification, and employee selection. But an ergonomic program can be most effective if you and everyone else in your workplace maintain an ergonomic culture. This involves reporting symptoms when they develop to allow an assessment and possible intervention to be launched before injuries can arise, and encouraging others to do so also. It can only benefit you and your fellow employees in the long run, and will result in fewer injuries and increased productivity.